Welcome back. We just implemented a thread shutdown mechanism using a Boolean flag. Let us now run this code, observe the exact behavior you may see, and critically analyze the efficiency of this polling approach. 1. Execution review with correct output. When we run the script, we see the worker thread start immediately and print working. The signaler thread prints its intent to wait 2 seconds. The worker continues printing working several times while the signaler is delayed. This concurrent activity is expected. Once the signaler sets the flag, the worker's next check causes it to break its loop and terminate. Functionally, the shutdown is successful and controlled. 2. The problem polling, also known as busy waiting. Although the worker thread uses time.sleep parenthesis to simulate work, it is still consuming CPU time on every half-second iteration just to check the flag. If the worker's task was short, say a few milliseconds, it would be checking the flag thousands of times per second. Polling is like constantly looking at your clock while waiting for the next minute to start. It is an inefficient use of resources because the thread is active but not performing meaningful work until the flag changes. 3. The solution, event-driven communication. The goal should be for the waiting thread to consume 0 CPU resources until the event happens. Instead of polling, we use a mechanism where the thread can explicitly go to sleep and be woken up only when another thread signals the event. This is the wait and notify pattern, which maybe we will see next. To summarize, we must transition from busy waiting to blocking communication. Our next lecture 26.17. Thread communication using wait and notify. See you there.